Hello everybody, I will start my today another live coding session. So in today's video, I will solve this question. Longest palindromic string. So in this question, I'm giving string S and I will return the longest palindromic substring in S. So palindrome is like ABA or ABBA. The strings which with the same form backward. So now, for example, if I'm given BABAD, BAB is the longest palindrome substring, so I will return BAB. And in the case CBBD, I will return BB because it's the longest palindromic substring. Okay, so in this question, the input should be string S, and the output should be the string, not the ranks, actually. Okay. So, and obviously for some edge cases, if S is an empty string, I just have to return an empty string. And S consists only of digit and English letters. Okay. And the palindrome can include digit or English letter inside. And no blank spaces. Good. Okay, so let me think of this question with some examples. For this case, first I can say, actually, each single character is already palindrome. Yeah, because obviously it's true. And for BAB, yes, this is palindrome. And ABA, this is also the palindrome. And since like I can return any of them. Yep. Oh, so that's something I had to clarify. If there is a tie, I can return any of them. Good. Yeah. Nice. So I will return BAB or ABA. Okay. I think the brute force approach is that I will think of every substring, like B, also A, and also BA, BAD, every substring, and then I will check if it is palindrome or not. And in that way, for only the palindrome substrings, I will return the longest one. So that's the brute force approach, and the time complexity of this approach should be n cubed, because the combination of start and end should be n squared in O big O notation. And for each substring, it will take O of n time to check if it is palindrome or not, because I have to do the linear scan. Maybe I will use the 2 pointers from, leftmost character and rightmost character in the substring, and 2 pointers are going closer. So that kind of two pointers approach can be used to check if the string is palindrome or not. So in total, it should take O of O n squared times O of n is O of n cubed. But I can speed up more. So I think I can use the 2 pointers. Actually, I can solve this question with dynamic programming too, but let me introduce the 2 pointers approach first. So for example, in the 2 pointers approach, what I can do is I will expand from the center factor. So for example, if I say, oh, I think this is the center character. So in that case, I will expand the leftmost character and rightmost character in, left forward and right forward. And firstly, I will expand this BAB, and yes, this is palindrome. I can just find I can just check if the newly added leftmost character and newly added rightmost character are the same or not. If the same, I could expand the palindrome. If not, I can immediately finish there. Because previous one was the longest palindrome whose center is the character I chose. In this case, A. In this way, from each char, I will expand left and right until it is substring. No. And then when it isn't, I break and check the next center character. And also obviously, every time I see the longest palindrome, I will update the returned string. Yep. And I will finally return the longest, palindrome substring. But one thing I have to take care is center can be here, the character, or the center can be between two characters. For example, in this case, I can take here as the center, then I can expand in this way. This is completely valid. So when I first re-expand, it should be AA and it's still palindrome. And when I expand one more time, it becomes BAAB and it's still palindrome because B is equal to B. Yeah. So I can say I have to check this also. Each, how should I say? Each center, each char, each space between. Okay. So this is the basic approach I can take, and the time complexity for this approach should be O of n squared, because this character spacing between, so there are n characters, and obviously there are n minus 1 space in between place. So it should be n, or I should say 2n iterations, steps, and I will try to expand it. In the case, say the string is just like A. In that case, from each center, I will expand the palindrome until it reaches the beginning or end of the original string. And in many cases, it takes O of n or around almost like that. So, for example, here, in this case, if I start from here, it will take only 2 steps because leftmost character, because there are only 2 leftmost characters. Sorry, there are 2 left characters, but around here or here or here, I have to do almost n divided by 2 steps because it's almost the center. So I can assume that for each character, I have to do over n characters traversal in the worst case in big O notation. Yep. So multiplying them, I will get n squared. Okay. For space complexity, I don't have to I don't have to store anything. But here in line 23, I don't want to update the return string every time because it takes time to create a new string in Python because new object is initiated. So instead of this, I will update return kind of longest range, this should be tuple or starting next and ending next. In this way, I don't have to initiate substring every time I find the candidate, but I just have to initiate it in the end, and we should be returned. So no extra space. Yep. And also time complexity. It doesn't take extra time here in line 23. Okay, the being said, I will implement this approach. Okay, so first thing I can do is setting the left and right pointer first. So I can show you how I did it. So I will take I as the center. So let me just say center for clarity. And left and right should start on here this way or this way. Yeah, in this way, actually for this case, I can say I took the space in between A and B as the center. So I could cover both of the two cases I've written in line 21. Each shower, each space in between. And C can be from here to here. Because it here, oh, it still works. Okay, so I can say it here, when this is here, left, right is like this, but also left, right can be this and this. But this is invalid. So I have to, ignore this. So yeah, this is how I can ignore this. Okay. Mm. Good. So now I will start the 2 pointers. The first thing I will do is okay. So Okay, so here what I did is I included the check of palindrome in line 49. The condition I have to meet is firstly, left and right are in the bounded range. I mean, in the range of the string. And also, left char is equal to right char is needed to expand the palindrome. And that being said, I've noticed that I don't need this condition, line 46, 47. I don't need this check because if left and right begins from the state I've written in line 37, in line 49, this is immediately false because right is not less than n. So I can completely ignore this case. So this is enough. Okay. And what I did is, once I find that this is a palindrome, I will check if longest is the current longest one. And if so, I update the longest range. Okay. So now I will check. Oh, I will return string. Like this. Good. Okay, so I will walk through my code. I will check the case if it is BB. In this case, n is 2. So center should be 0 and then 1. I will check center 0 and center 1. And for center 0, I will check 0, 0, and 0, 1. So far looks so good. And for 0, 0, this is true. Yes. Because b is equal to b and index 0 is inside the range. So now in line 55, current ranks is 0 minus 0 plus 1 is 1. Longest ranks is 0 minus 0 plus 1 is 1. They're the same, so I don't update longest range. And come back to line 52. And I will start with 0, 1. And I will omit, but the same thing happens here. Oh no, sorry. When I start with 0, 0, oh, after finishing the check here, I have to update the 2 pointers. I have to move 2 pointers. In this way, left becomes -1, right becomes +1, and left is now out of the range, so I finish the while loop after that. Okay. And next, 0, 1. In this case, yes, the same thing happens. I will omit. No, I don't omit. Not the same. Because in line 53, this is true. Left and right are in the range, and b is equal to b. Now current ranks is 1 minus 0 plus 1 is 2. So longest ranks should be updated. Sorry, longest range should be updated. So longest range becomes left, right, which is 0, 1. Okay. And then I update left and right pointers to -1 and 2. And obviously -1 and 2, each of them are out of the range. So I finish the while loop here. And I come back to line 51. And if center is 1, the same thing happens. But I'm pretty sure it doesn't update the current ranks. Sorry, longest range. Yeah. Yeah. To save my time, I will skip the iteration. Yeah, but in that way, I get 0 and 1 as the left and right. So in line 64, I return the whole string actually, which is BB. Good. Okay, so now I'm pretty confident in my code, so I submit. Hmm. Okay. So seems like last two characters are returned somehow. Yep. So AD is returned, which is obviously this. But this is actually not palindrome. Hmm. Ah, I remember this. Firstly, I decided to take center. Sorry, center can be the last index. So that's one thing I have to update. And what happens is that still the last string possible is returned. Mm. Oh, wait. I have to use left and right pointer index from longest range. So it should work like this. Okay. Good, accepted. Okay, so this is the first approach in which I used 2 pointers. I have some time, so I will introduce a few more approaches. The second approach should be using the top-down DP. So when I have ABBA, I will think what's the longest palindromic substring in this range. And just like I did in the, 2 pointers approach, I will check if this and this, the leftmost chair and the rightmost chair is the same. And yes. And also, the inner substring is palindrome or not. If both of them are true, I can say ABBA is palindrome. Or I can say something like this. In this case, leftmost chair is equal to rightmost chair. And there's no inner string. So I can say this is substring, no palindrome. Also like this. Left pointer is right pointer, and they're the same. Obviously, both of them are B. And also, I don't have any inner string. In this case, also, this is palindrome. So what I can say from here is that I can check if the string is palindrome or not recursively. As I said, I will check leftmost chair and rightmost chair. Then I will take a look at the inner string, and I can check if inner string is palindrome or not recursively. So that's how it works. Yeah. So obviously I can use the top-down DP here. So the interface looks like this. So also one benefit is that once I check substring in some range is palindrome or not, I don't have to check it anymore one more time. So by caching the result, I can, you know, avoid the duplicated work, which is so good. Yeah. So in this way, I can solve this question. One thing I have to take care is that I have to start not only from 0, 0, sorry, 0, 3, but also I have to start this check from this range or this range or this range. I mean, all the ranges. Because if I pass 0 to 3, it just checks if this is palindrome. It doesn't check if this is palindrome or not. So that I have to take care. So what I do is each left right pair. I will call this recursive function, and if true, I will update the return range, longest range. Yeah, so this is what I will do. So for time complexity, here in line 15, there are n squared pairs. But I actually don't have to think this too much. I can think of it in this way. The problem I have to solve with this recursive function, the argument left and right has n squared pairs. And for every possible n squared pair, I have to calculate the result. To calculate the result, it takes a constant time to check left is equal to right or not. And I will do the recursive function call that. And I can say, excluding the recursive function call, this is palindrome method takes constant time. So, and once the result is calculated, I don't have to calculate it anymore. One more time. I can get the result in the constant time. So I will try n squared pair of argument, and for each, I can say it takes the constant time. Because, recursive function called time, I mean, the time to execute the recursive function call should be included in the time which takes in the inner, recursive function call. I mean, Corey. It's calculated it is added to the Corey time complexity. So that's how I can say it takes O of n squared. For space complexity, I need the recursive function stack, and it should take up the O of n, because every time I call the recursive function, the range of left and right should be decremented by 2. So it takes O of n space. I mean, O of n recursive function stop length, there should be O of n space. Good. Now I will implement the longest palindrome. One thing which is good about this is I could confirm that here S consists of only here length of S is 1 or more. If this is 0, if S can be empty string, run 25 doesn't work. I have to check it first. But because it has at least one character, I can say the first character only is always the palindrome. So I set it as the default of the longest range. I will do this logic here. Okay. And then I will return the palindrome here. Good. Okay. So now I implement the isPalindrome method. So I can say no. For the edge case, I have to take care. Yep, I can say this. Otherwise, I will check. Oh, sorry. And here I should return true because if left is bigger than right, which means that I could shrink the left and right pointer without any problem until the end. So this should return true. Or I can say yeah, I think this is more intuitive. So if right and right pointer is pointing to the same character, it should return true. Or right pointer is adjacent to the left pointer. If there's the same, I can return true. And also I can say I can simplify a little bit. Right. No, I think this is good enough. Yeah, I don't want to. Yeah, make it. I don't want to make a change. Okay. So this works. This is how I've implemented it. So let me check it again. So left is equal to right. In that case, I return true. And left plus 1 is equal to right. In this case, if two characters, left and right, are the same, I will return true. Otherwise, I will check recursively. Firstly, if left chair and right chair are the same. And also I have to check if the inner string is substring or not. Good. Okay. One thing I have to update is this. I submit my code. Oh, S is not defined. Yes. Good. Memory limit exceeded. Oh, sorry. Here in space complexity, this should be O of n for recursive function stack. And also, I need the n squared for caching. Yeah. And obviously, this is a problem. Cache has a left and right combination, which is n squared. And value should be only the, Boolean. So in total, it should take n squared space. I thought so. But now I'm caching string s also. This is the problem. I don't want to include this s into the cache because it takes much more space, which leads to memory limit exceeded. Okay. So let me make it a shared variable. Okay, I think this now works. Hmm? Still, it doesn't work. Maybe n squared space is not acceptable in this question. Yeah, it seems like so. I checked my past submissions and found that it always memory limit exceeded when I use this implementation. But anyway, I could solve this question as top-down DP. The last approach I will introduce is to use the bottom-up DP. Yep. So it's almost quite similar to top-down DP, obviously. So what I would do is create a 2D, 2D DP table. This is the start index, and this is the end index. And say if I start from A or B or B or A, for each case, everything where is the end character? Okay. So if it starts from A and end with A, this is palindrome. Yes. Okay. So let me explain the DP table first. So this position signifies this begins from A and this begins with A. So it represent A. For this one, this string represent this position represent ABB. For this should be ABBA, and for this should be only A. And I will fill in the boolean if that position's substring is palindrome not into this DB table. Yeah. And also I have to say these positions are invalid because it begins from some character and ends with character before. So my task is to fill in these positions and remaining positions. And also when I find true, I will update the longest range, which should be used in the end. That's something I just used in the last two approaches. Yeah, cyber updates them. Yeah. And when I fill in this DB table, I have to take care one thing. So how I can use the result from previous result. So it is, for example, I direct to check if ABBA is palindrome or not. Just like we did before, I will check first. The first character is equal to end character. So this is true, yes. I'm trying to fill in this here. The first condition is start is equal to end. This is true. In that case, I will take a look at the inner string. Inner string begins from start index plus 1 and end index minus 1, which means start index minus 1 and this position. Yeah. So every time I try to fill in this cell, fill in some cell, I have to take a look at left bottom adjacent cell. Yep. So that bottom left adjacent cell must be filled in first. So I will try to fill in the DB table in this order. Firstly, the diagonal cells. Then here. Then here. Then here. So in this way, I can fill in the DP cell in the constant time for each cell. Okay. So this is how it works. That being said, the time complexity of this approach should be n squared. As I said, I have to fill in each table, each cell, and each takes the constant time, so it should be n squared. And maybe I need to do some operations on updating longest range and yeah. But as I've seen so far, it takes a constant time only. Because I don't have to create the slice of the string. And for space complexity, it should be on n squared for the DB table. And that's it. Although I have to initiate the return string in the end, I don't include it because it's the return string. And also it only OON. Okay. Now I'll start the implementation. I start from this and then this and this. So, and firstly, I start traversal from here, then here, here. Start is always 0, and end is 0 to n. So this start n is this, and then this, and then this, and this. So I will do update start +1 and then +1 from here to go to this direction. 1, 1, 1, 1. So no. So this. Okay, so I can say if I start from here, the next position is here. So, and I have to check if this is in the boat. So while it is true, I move the start and end index. Okay, and I will check, try to fill in the DB cell at this start end. Okay. And the kind of base case is that for this number 1 cells, it's always true because it's a palindrome. And it has, it has the only single character. Otherwise, I have to check if start char is equal to end char. And also I will check the, as I said, bottom left adjacent cell. Okay. Good. Nice. So wait, also I have to take care if n is start +1, like this. If I start from this, I have to check if this is palindrome or not without seeing the previous cell. Because the previous cell, or I should say, bottom left cell of this should be, the, here start is 2. But if I take a look at start +1 and -1, it's now reversed. The order is reversed. So it's not so good. So what I can say is here, I will also include this as the other kind of base case. So that's what I will do. And as I said, if this is true, then I will update the longest range, just like I did before. Okay. As I think this works. Let me execute my code. I will omit walking through my code because I'm a bit tired already. I see. I used end and start. Good. Okay, so I will check what the DP table looks like. So somehow 00 is not filled in. I don't know why this first row is not filled in. Maybe I started from start 0 and end from each cell. I think I start from 00. Yes. Wait. I do this initially, but I have to move this index after in the end. I mean, in the end of this iteration. And I will try this case. No. Sorry. So I will check this and this first here. Is the current start and is in the buried position. Then I move start and end in the end of the iteration and check in the next iteration. Good. Now I submit my code again. Okay, now it's accepted. Great. So in this video, I introduced 3 approaches for this question. So the question itself is, I'm giving string S and I will return the longest palindromic substring. And the first approach I took was to use the 2 pointers expanding from center, from each possible center position. One thing I had to take care is center can be each character or each space in between 2 characters. Okay, and the approach 2, I use the top-down DP. Yep, and the recursive function interface look like this. And also one thing I had to take care is I had to call this recursive function from each possible combination of left and right index. And the final approach was bottom-up DP. So I filled in 2 DDP table. And in this approach, one thing I had to take care, I mean, 2 things I had to take care was, number 1, I have to fill in the DB table in the smart order. This number 1, number 2, number 3, number 4 order. And also, the other thing I have to take care is the cells with number 1 are edge case, and also cells with number 2. These are also base cases. So I distinguish them like this in line 40 to 43. Aside from these cases, these cells, I could think of them recursively. Yep, that's it. Oh, and through all these approaches, I didn't initiate the substring all the time, every time I find the wrongest candidate, but I just update the candidate range, longest range, and initiate the substring in the end of the method. This also, saves the time and space because I don't have to initiate the substring every time. And in Python, creating the string takes overwhelming time, so I could avoid it. That's one more thing I had to take care. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.